Hello all, I am presenting today analytical study of effects on business sectors during pandemic, a data mining approach. Authors Samruddhi Pawar, Shubham Agarwal, Dr. Prafulla Bafna. I am Dr. Prafulla Bafna, Symbiosis Institute of Computer Studies and Research, Symbiosis International University, Pune, Maharashtra, India. So now let's start with introduction. In introduction, we can see that there are different sections which are combination of management topics and the data mining topics. So first let's start with the motivation of the research, that is business sectors. This research particularly talks about the idea that what were the predictions of for the businesses in pandemic. In pandemic recession, there were different business sectors and most of the people think that doing business in recession is bad idea, but it's not true. The best example of this is it's from right from 1929, right from Disney World to 2016. So Disney survived the Great Depression in 1929, Netflix from dot-com bubble in 2000, and even in financial crisis of Airbnb, there were, that is in 2008, Paytm from demonetization in 2016. So though there are different examples which state that though certain situation come like pandemic, the most of the businesses need the prediction in which you can talk about different values. So evolution of small businesses also can be applicable for this particular study. When we are talking about this particular thing, we can say that March April 20 was the period where COVID-19 phase was there, and it affected the economy, and it was a literally downturn for so many countries, selected countries we can say. So what we have done is we have tried to suggest that though there is pandemic recession, using data mining technique we can have different strategies where even during the recession there won't be a loss in your business sectors, and classification and prediction are used to predict and to evaluate these decisions which are output by clustering. So the unlabeled data was considered, and that's why clustering, which is an always challenge for any of the sectors, is being implemented. Predicting price action of various commodities and securities was the need to study, so that the people who have lost their businesses because of this study can have some derivations or some suggestions, and then analysts and derivative traders need to make a better choices during the period of recession. So all this is basically the agenda, or all this is basically the need of the study. Now you can see here data collection was done, then classifier was applied, then classifier and clustering is used for the prediction, and then the performance evaluation is being done. The method of identifying the similar groups of data is important, and which is achieved by the clustering. So it is one of the popular technique in the data science in which some similar entities are being grouped. So we have made here three groups which eventually we are going to see in the next slides, and in this we will be talking about the clustering and their performance evaluation, and then we will be talking about clustering methods that we have considered. As I said already that the data input data set is about the sector based companies across the Nifty 200. In the performance evaluation, you can see that the graph was plotted for 30 days, 60 days and 19 days. So the graph was plotted for 1 month, 2 months and 3 months, and these are predicted ups and these are actual ups. So these values you can see in the confusion matrix about predicted and actual, about ups and downs in the market. So this is termed as confusion matrix. Now you can see here three clusters in which, so in k-means clustering, the k is demonstrated as 3. So we have chosen 3 centroids, and based on the distance which is considered by k-means, you can see that 3 different plots are there. What these plots are indicated that we are going to see in the hierarchical clustering method, which will be our next slide, in which I will be telling you the details of how these clusters are being named. So as I have said that we were having the data set which was not labeled, and the clustering was our first challenge. So this is Nifty 50 index, that data set is being shown, and this data set is being clustered into 3 groups. After it is being clustered into 3 groups, we need to identify what names you can give to these clusters based on expertise, based on the different types of the groups which are formed. So high volatile, medium volatile, and low volatile, these are 3 different groups which you can see, and these 3 different groups has their associated constant, and you can see here the names of the company. Though names of the companies are not being focused significantly, but the important information to understand over here is the entire data set is classified into 3 groups. So as I have said that we were just having the values of ups and downs, and we were not having the values of what type of groups it is having. So what we have done is these values are being clustered using k-means and hierarchical clustering, and then these are grouped as high volatile, medium volatile, and low volatile. So you can see that in conclusions we have predicted stock prices in multidimensional factors oriented environment. We are saying it as multidimensional because we have considered all the attributes which were present in the data set, and we have not used any expertise, and we have not reduced the features to get the comprehensive data look. Then we have applied k-means clustering and then hierarchical clustering. I have already shown you the k-means clustering with 3 groups representing by 3 different colors, and hierarchical clustering is nothing but the dendrogram or tree like structure. So if you see here, k-means clustering was having 78% accuracy, and hierarchical clustering is with 70% accuracy. This accuracy was compared using Silhouette's coefficient. Silhouette's coefficient is that constant which is associated with understanding the width of the clustering. So width of the clustering, if it is greater than 0.5, then that clustering is considered as standard clustering. So in this we have considered both of the clustering with Silhouette's coefficient evaluation, and its Silhouette's coefficient is good for k-means clustering, and that's why we are predicting that k-means clustering is better in our case than hierarchical clustering. The parameters which we have considered to evaluate are cluster withinness, cluster totalness, cluster width, which are nothing but those represent the members of the clusters, that is what are the points in the clusters, what are distance between 2 points in the clusters, then the distance between the 2 clusters, and sum of all these distances and average of all these distances. Based on these values, the evaluation is being done using Silhouette's coefficient. So basically Silhouette's coefficient uses all these parameters. So that's it from my side. These are some references which I have used in this research paper. Thank you so much.